Hi, my name is Scott Moore with Moore Engineering. I'm here today to instruct you on the use of the BOT-3000E digital tribometer. This device is designed to measure the coefficient of friction of flooring surfaces. What this means is that we'll be using the BOT to measure the frictional forces of a flooring surface that a body encounters when it's in motion. This frictional force is trying to stop the shoe from moving, and therefore, the higher the dynamic coefficient of friction, the less likely the shoe is to continue sliding and cause a fall. The dynamic coefficient of friction is therefore representative of the safety of the flooring surface. Let's start with the basics. Each BOT-3000E tribometer comes with 2 rechargeable batteries. These batteries are not to be stored within the BOT itself and must be removed and stored in the case after use. The batteries are charged using the included charger within the BOT case. To charge the battery, place it in the charger. When placing the battery in the charger, you will see a red light appear on the front of the charger. Once that light turns green, your battery is charged and ready for use. Place the battery inside the BOT once fully charged. You should hear a click when you put the battery in properly and should not have to use excessive force to place it in the BOT. Once the battery is properly inside the BOT, you may press any of the 6 black keys on its face to turn it on. Now, as you can see, there are a bunch of options to select on the main menu of the BOT. So I'll walk you through a few of these screens that are valuable during your testing. First, we'll start with calibration. This is essentially the yearly calibration of the device, which is completed by the manufacturer and is critical for its continued reliable and accurate operation. It is important to remember that before you conduct any testing, you must verify that the device has been calibrated within the past 365 days from the date of its use. The last calibration date will be included on the PDF reports created by the BOT. To do this, we'll have to scroll to the next page on the BOT screen, where calibration is available. Press the black button next to the arrow in the bottom right-hand corner. At the top of this screen, you'll see options. You'll see Calib as the second option down on the left-hand side of the BOT screen. This page will read facts about the force adjustment, offset, and sensor position. For now, we'll just worry about the calibration date. This date is the last date that the BOT was calibrated by the manufacturer. In order to have your BOT calibrated, you must send it to the manufacturer. Taking a look at our calibration date, this BOT appears to have been calibrated within 365 days of today. You may select the back button to return to the home screen. Once you have determined your BOT-3000E tribometer has been calibrated within the past 365 days, you must verify the calibration by using the verification mass included with your BOT-3000E tribometer. To start this process, stand the BOT upright with the printer side down. In order for the BOT to pass verification, it must be both properly calibrated and on a level surface. Take the cap off the verification mass. This will be inserted into the BOT in the same space that a sensor will later. Insert the triangular top of the verification mass into the corresponding space on the BOT. Do not adjust the mass any further once you have placed it inside the BOT. It is important to be aware that the verification process will not work if there is any movement, vibration, or even airflow around the device. The verification option on the BOT will not appear until you place the verification mass inside the BOT. Click the button next to the word Verif, short for verify. By pressing the Verif button, you will begin to activate the mass. The BOT will beep and boop and read positioning mass. You will also see the tilt measurements move at the bottom of the screen automatically. The BOT will then ask you if you would like to verify the system. Press the black button next to the Start option to begin verification. After pressing Start, the BOT screen will read Verifying. Then the screen will notify you with either a passed or failed message. You now have the option to print the proof of past verification, or select back to reset the verification. If your BOT passed verification, you may proceed with testing. However, if your BOT fails, repeat this process, placing the BOT on a flat level surface and being careful to mitigate movement in and around the area, such as walking, and make sure there is no airflow through the area. If the test will not pass after multiple attempts, there may be an issue with the machine and the manufacturer. My BOT won't verify. I need help. After passing verification, you may exit the verification screen by pressing Exit. The BOT will beep, boop, beep, and read Remove Mass, and then reset to the main screen. You may now safely remove the mass and return it to your Pelican case. Next, we'll be taking a look at the data section of your BOT-3000E tribometer. The bot records all data as you make your measurements and complete each test. This will make more sense later as we begin some of the testing. To access the data screen, we will need to go back to the options screen. This is where we access the calibration tab by pressing the black button next to the arrow at the bottom right-hand corner of the screen. By going to the Data tab, we can view the data records stored on the bot currently. The data shows the date, time, and results of each measurement taken with the BOT-3000E tribometer. If any data is currently stored on this bot, it will appear here on the data log screen. You can press the arrows to pan up, down, left, or right throughout the data. These measurements will make more sense later as we begin testing. If there's no data stored on the bot, as it should be between uses, you will see the message No Data Records. Now we'll discuss the collection of data and use of the bot. As you begin taking measurements, you can assign unique identification codes to correspond to individual test locations. These codes are numerical and controlled by the user and should correspond to the different locations and areas you are testing. The location identification codes typically refer to the test locations that fell within the physical building, facilities, or sites. Area identification codes typically refer to physical buildings, floors, or other facilities. You select these different codes prior to taking measurements for each test. These codes will present on your results reports after your testing is complete and will help you to identify which location and area codes correspond to individual test locations. Pro tip: it is recommended that you draw a map and indicate on that map what your area numbers and location numbers are, so that later on you can correspond those values to what you've already done. For measurements of different locations within an area, you use the buttons next to the plus and minus options, increasing or decreasing the location IDs. The same goes for your area ID numbers. You can also change the distance at which the test is run. Standard distance for the ANSI A326.3 standard is 10 inches, but in circumstances where areas are tight, you can use lower test run lengths, as long as they are indicated within your report. Your bot also takes test location photographs. These photographs are incorporated into each test report and are taken automatically with each measurement. Single test runs will only document one photograph. The initial camera takes a snapshot view of what is in front of the bot. So as you're testing, remember to smile, because you may be on camera, as if you weren't smiling already. At any time, you may print copies of test results and verifications from the print screen. Note that printing this information is not necessary when testing, as all of this information will be automatically included within each test report. To access the print screen, you tab over twice from the main menu using the button next to the arrow in the bottom right-hand corner of the screen. Here you can print a multitude of things, such as results, verification, A326.3, or any other standard results you may be testing to. When commanded, the requested data will print from the rear of the bot closest to the user when viewing the screen, and will print on thermal paper inserted into the bot. To insert a thermal paper roll into the bot, apply pressure to the plastic tabs on either side of the access panel and pull the door open. Place a new roll inside with the loose end facing upward and outward with a bit of paper sticking outside of the bot. Close the door shut. As mentioned earlier, at the completion of your measurements, a test report is generated automatically by the bot. These reports are in PDF format and show the measurements, location, and area IDs, and also include the images taken by the bot during each measurement run, along with the calibration date and most recent verification. In order to access these test reports, you must transfer them off of the bot and onto a computer. This you can do via a USB memory stick. The bot also creates a text file containing the test results in CSV format. Before I go any further, this is of utmost importance. It is absolutely critical that you understand that if you delete the data off of the bot, there is no way to recover it. So it's very important that you make sure that you copy the data off of the device onto your USB stick and onto your computer before deleting the data from the bot. Personally, I like to transfer the data off the bot first and onto the USB, then check to ensure that all the data is accounted for by viewing the USB data on the computer. Then I like to store the data in its proper folder for each test project, as well as a backup folder. And I also check to make sure it is still on the USB after I've copied it onto my files, before I delete the data from the bot. Now back to business. So the maximum size USB drive permitted during bot data transfer is 16 gigabytes, and the drive should be formatted to FAT32. Place the USB into the rear of the bot. To transfer the data off of the bot and onto the USB, pan over to the options screen by selecting the black button next to the arrow in the bottom right-hand corner of the screen. Once on the options screen, select the black button next to the USB option. The options to transfer the USB are seen on the File Transfer to USB screen. The different buttons on the screen allow you to choose to transfer all archived and new files, choose to delete the archive, choose to transfer the new file since the last transfer, or go back to the options screen. By selecting the transfer data, you will be prompted by the bot not to remove the USB. If you remove it, you may lose important data. The bot will tell you when it is done with the transfer. Once your data has completely transferred, you may hit the back button to reset the screen, and then can safely remove the USB. It is at this time, when the data is on the USB, that you can do what you would like with it. After the data is safely stored elsewhere, you may delete the data off the bot if desired. It is important to note that if this data is not deleted, the bot's storage is limited to 500 new records and 1,000 archives.